I will, let's see, share screen. Should be pushing to you now.
That's great. We can see that.
Great.
So let me just do a quick introduction. So Doug Miller is a senior associate at the Rocky Mountain Institute, and you're responsible for buildings and disruptive technologies there, I think. Doug, is that right?
Yeah, for sure.
Long history of working in sustainable technologies, including stints at Imperial College and Oxford University and University of Pennsylvania and Wharton School of Business. So thanks so much for agreeing to give the talk. Let me just pass it over to you.
Great, and thank you for having me today. And my goal for the conversation is to offer a brief summary of the work that Energy Web Foundation is doing and focus on one specific example that's actually specific to the United States in terms of an exciting new collaboration that we have, and hopefully give a better idea of how this new technology applies to the energy sector specifically. I will give a roughly 15 or so minute presentation. Then I want to open up the floor for Q&A because I imagine there's going to be many questions that come up. I want to dedicate the majority of the time to that. So with that, I'll get started. And I should also begin by saying that you're not necessarily going to know entirely how blockchain technology works by the end of this presentation, but more importantly, how this new technology applies to energy. So with this first slide, when EWF, when we think about blockchain, we see it in the broader history of computing. So when you take a step back and you see, when we look at how blockchain fits in, we look back, a half century ago, where we had the initial development of hardware, led by groups like IBM, and then over time moving toward the development of software so that people could actually use the hardware in new ways. Then moving forward to the most recent decades, the transition toward networks and ability to interact with others using computers in different ways. And then now with blockchain development as a technology that further builds on networks and allows for different ways for people to transact. And with each of these developments, we sort of see a period of expansion of what are the different opportunities, a whole bunch of different players coming into the mix, but then over time, both consolidation in terms of who the market leaders are, and then commoditization in terms of people actually delivering and deriving business value from it. And for those who aren't, I'm sure folks are familiar with the first three logos here. The fourth is Ethereum. And from us, EWS perspective, we see Ethereum as the general leader in terms of in the blockchain space right now. And when you try to think about how blockchains, what blockchains are, we generally think about them as decentralized networks. But at the same time, actually, I'll take a step back. The first ones to date, like Bitcoin, they really just served a single purpose. And so, with Bitcoin, it was something that it's a source of value and a way to transfer value between entities. So it's in a way like a hammer. It does one thing. Now with some recent developments in Ethereum, you're seeing people build applications that maybe do a handful of things. And as people want it to do new things or envision it doing new things, they sort of add another tool set. And we sort of see recent developments in the blockchain space as being sort of like a Swiss Army knife. It can do a couple of things that don't really connect that well. Where we want to go, where EWF is heading, is to really enable blockchains that can serve any business or business purpose or other need that people may have. For those of you who have read anything about blockchain, you might come to a conclusion of, well, what is really different? As I just said, we think about it sort of as a decentralized network. If you're really being, in a way, critical, a way to think, it's really just a decentralized computer. It's a way to create user accounts. It's a way to read and write data securely. It's a way to write and run programs. And so this begs the question, well, if some of what blockchain does is something we already do with computers, why is this interesting? So when you think, when EWF thinks about the energy sector, and as many other folks in this space think about it, we're seeing a major transition from the way the energy system has worked in the past to where it is heading, and already seeing developments in this area, where historically, as many of us know, the energy sector has been driven by large centralized fossil fuel-based production that's then sold and moved toward inflexible sources of demand. We see major developments and a lot of indications that we're moving to a new energy future, where instead of this essentially hub and spoke model, that instead we're moving to one of more distributed energy resources, both in terms of distributed, in many cases, smaller renewable energy production that's variable, to also having flexibility in terms of energy consumption on the demand side, in terms of responsive smart devices in our offices and buildings. And what this implies is an inherent increase in the amount of complexity in the system. So historically with utilities, they've had to manage several thousand, let's say, customer accounts. As we move to a future where there's more changes throughout the day that have to be managed, this is a transition to millions of devices rather than thousands of customers, which means we have a lot more of combination of accounting work, but also management and transactions to make. And this is really where we see blockchain coming in, is to support this in the energy sector, supporting this transition to support the greater complexity. And because in this complexity you have more people interacting with one another, with different organizations, and more machines. From everything from the rooftop solar system to an energy meter to electric vehicles, and so on. And blockchain technology, we believe, is an important one in combination with others, like IoT devices, to establish more transactions at the device level, where devices start to actually act like market participants. And in that environment, blockchain is a way for these devices to transact with one another, to provide the proof that certain things did in fact happen, that the parties were paid, and creating that full history. And in many cases too, to enable automation of things that whether it's a utility wants to do and or their customers want to do. So a year and a half ago, or actually we're approaching 2 years ago, Rocky Mountain Institute and Grid Singularity, so a influential clean energy nonprofit in the US, RMI, and Grid Singularity, a blockchain energy company based in Berlin, co-founded a new nonprofit based in Switzerland called Energy Web Foundation, or EWF. And EWF is a nonprofit dedicated to the decarbonization, democratization, and digitalization of electricity worldwide. And EWF is doing 4 things listed here. We are building a core technology. So those of you who are familiar with Bitcoin and Ethereum, EWF is building the Energy Web blockchain, which is an energy sector specific blockchain that we're building in specific needs to meet the needs of what we're hearing from energy sector participants. We are also facilitating an ecosystem of energy companies, utilities, startups, and app developers. And so this includes what we call Energy Web Foundation affiliates. And these affiliates have been have been critical to the funding of our work on the core technology to date. And so we have currently about 80 affiliates. And we have other groups that we partner with as well that are both the sources of input as we design the infrastructure, but also the groups that can test it, deploy it, and also ultimately build the applications. We are engaging regulators, and even more now that we've reached the second phase of our development, to get their input and make sure we're meeting needs from everything from the energy sector specifically to considerations for new data privacy needs, such as in GDPR in the EU. Lastly, we are accelerating the development of applications. and this is where I'll focus sort of the remainder of the presentation here. As I mentioned before, we're building the core infrastructure, which you can sort of think of as the roads and the highways of a new digital energy future. It's where we see people building and running apps. And to help get applications a running head start, we are building frameworks and tools to help people with building applications. To provide a visual to better explain what we are building, EWF's work is this purple area in the middle. So on the bottom layer, we have the physical world, the wind turbines, solar panels, meters, electric vehicles, the actual the stuff that's doing things that have data about it. And we are creating the interface between that and then applications in the green layer that people may build for renewable energy trading, for electric vehicle charging stations, for demand response programs, etc. And EWF is doing the piece in between. So it's the actual infrastructure, the governance of that infrastructure, how people use it, pay for their use of this system. And as I mentioned before, offering frameworks that help people make progress toward the green layer to actually build things. Just in a nutshell, here's some of our more recognizable affiliates. In the US context, our affiliates include Exelon, PG&E, Duke Energy, Sempra, and a few others. I mentioned that we are accelerating the development of different applications. These were the top 5 identified areas that we identified at our kickoff workshop about a year and a quarter ago, where we came to our affiliates saying, we've identified roughly 15 application categories that each represent at least 1 billion in global annual value, some being in the tens of billions per year, mainly in terms of cost savings. And we have working groups at EWF with affiliates for each of these different types of applications. And I'll now focus a bit more on the one on the top left, which is the focus of my work day to day at EWF. But before I do that, here's just a little recap just to show that we have activity from a couple of affiliates in each of these areas. So for myself and my day to day, working on certificates of origin, so renewable energy certificates, guarantees of origin, international RECs, and similar instruments around the world. We're working with here in the US with Exelon and somewhat with PG&E on this. In Europe, working with ENGIE, Equinor, and others. And then in Southeast Asia, working with the likes of PTT and Singapore Power. So to help, as I mentioned, as I said before, get applications off to a running head start, we built version 1 of what we call the Energy Web Origin Toolkit earlier this year, which we then set up 5 pilots for. We, in these pilots, showcased 3 types of things that we think are worth mentioning. The first thing is, for those who are familiar with renewable energy certificate markets, we showcased unbundled REC transfers. So the ability to buy and sell green energy separate from electricity sales, in other words. And we showcased this in 3 settings, where we connected renewable assets from ENGIE in France and Belgium, from Singapore Power in Singapore, and TWL in Germany, and transferred ownership over green attributes to 3 buyers in those same settings. So Microsoft, the Development Bank of Singapore, and E.ON. And that was a relatively straightforward example, but it's one that most, or many market participants do today. We also showcased 2 more advanced scenarios, one involving 2 German rooftop solar PV systems and our office in Berlin, where essentially we connected the 2 solar systems, and we also connected the energy meter from our Berlin office, and based on how much consumption our Berlin office had, so if we consumed X kilowatt hours today, Y kilowatt hours tomorrow, then that would specify the order that we would have transferred from the two household systems. So let's say we consumed 10 kilowatt hours today, and the household's combined production was 7 plus 4, let's say it was 11, then we could transfer over and there would be a balance of 1 that we could maybe put toward the next day if we need to. In the last scenario here, we showcase the ability to track the green attributes associated with electricity being stored on a battery and then injected into the grid. And this is something we also see relating to electric vehicles. We're currently actually exploring a couple of pilots that would involve ensuring to EV drivers that the electricity being used for their EVs are in fact coming from renewables, and to empower consumers to be able to know that and demand it. So with this work that we're doing on Energy Web Origin, some people probably would ask themselves, well, how is what you're doing different and exciting compared to the existing tracking systems? For those of us who have in fact interacted with existing renewable certificate tools and guarantee of origin tools, most of them are quite antiquated in terms of how they work. They're very manual, and in part because they were designed based on historical arrangements where renewable energy buyers depend on brokers to purchase renewable energy certificates for them, and then essentially manually update the system on the other side. And we want to essentially disintermediate the process so that when buyers and sellers choose to procure renewables or sell renewables, that automatically updates the system and creates a more normal user experience given where we are in terms of web technologies. So what we're really excited about with Origin and the applications that we'll run using this toolkit, which is open source licensed, is the ability to, with what we're offering, to track data at the kilowatt hour level, build something that can actually interoperate with other applications people might run for, say, batteries and for electric vehicles in terms of knowing where your energy is coming from, creating a user experience that doesn't require a third-party intermediary, allowing for more automation. So going back to those pilots I mentioned before, in the example, let's just say for Microsoft and Engie, for that one, Microsoft said, you know what, we want to test buying 10 megawatt hours per day because that's roughly our needs in France. And so then moving forward, every day in an automated way, based on actual production, 10 megawatt hours would be withdrawn from Engie's production and sold to Microsoft. Imagine more advanced scenarios like the one we did that I mentioned from our office in Berlin, where a buyer says, you know what, I want to buy exactly the amount of renewables I'm consuming based on my meter, and I don't want to have to deal with this anymore. I want the meter to just start buying the green attributes on my behalf. And this is something we want to enable. We're also excited because this will inherently reduce the costs if people don't need to depend on third parties for as much of their as much support or any support. That'll help drive down costs, some of the soft costs of renewables from our perspective. We also think what we're developing will increase or reduce the barriers to entry and increase market access in terms of smaller participants who want to, say household systems or small businesses or universities, giving them the ability to better aggregate their demand or aggregate their supply and participate in markets with everybody, including the largest buyers, the likes of Microsoft or Google or Walmart. Here's just an example showing what a transaction looked like in the version 1 pilot that we put together. In this case, it's just a screenshot of a user interface from, in this case, a transaction that we tested on April 12th of this year from Microsoft and Engie, where you see on the map exactly where the Engie asset's located, and you can see that 10 megawatt hours were transferred. The most interesting piece of this is actually at the bottom with the 2 lines of a many-digit item, where that's essentially the indication that the production being logged by Engie, and then next the transfer going from Engie to Microsoft, where those are actually already connected to Etherscan, which is a more or less generic place for tracking blockchain transactions. And so this is really just to show that there's full transparency already in the system around things that are happening. In terms of where we're heading, EWF does not plan to be the one who builds user interfaces, but for the purpose of showcasing what we're doing, we did build some test user interfaces, and this is just an example to show where we want the market to head, which is, in this case, think about how can we make buying and selling renewable energy the user experience more like when you book, say, a hotel or a flight, where just like here in this test user interface we put together and we use for the pilots, you choose the start date. When do you want to start buying renewables? What's the end date? What's your basic information as the buyer, and then allowing you to say, you know what, I want to buy wind power just from let's say the DC metro area, and maybe I care if it's wind, maybe I don't care, maybe it's any source of renewables, and maybe there are other business rules I want to add in, such as price, or maybe I'm even a more advanced buyer and I want to help develop new projects and I want to do something along the lines of a power purchase agreement or a PPA. These are the kinds of things we want to enable. So some of you may have seen the news from last week. We have partnered with the PJM market, so with PJM Environmental Information Services, EIS. And so over the next year, we are going to be testing what I have visually on the screen here, which isn't the best visual, but we are, over the next year, going to be sitting side by side with some folks at PJM to build a more robust version of this toolkit we've already begun testing that meets the needs of REC trading in the PJM market. And so what this means in practice is that we will be testing a couple of things. One is what we call the Energy Web Registry, which is a place where the IDs associated with any assets interacting with the Energy Web are stored to make sure there's, for example, no double counting of RECs. We then will be testing what we call an issuer toolkit, which is the actual tracking system that ultimately PJM would be in a position to adopt for its GATS system if it would like 1 year from now. Then on top, we would be testing a market toolkit, which is a place for existing players and potentially future players, where we want them to innovate and compete in terms of building even more consumer-facing applications to buy and sell RECs. And so what we'll be testing over the next year and developing and testing is a combination of this three-part technology stack and to test its ability to meet the needs of the volume and other functional requirements of the PJM market. What's exciting to it is that 1 year from now, when we're finished with this work, as I said, PJM will hopefully want to move forward with it, adopting an application that uses this toolkit. They are not required to do it, but we hope and expect they will be. In addition, though, since it's open source licensed, all of the work we're doing, we will be able to share this toolkit with any other REC or guarantee of origin or similar authority worldwide with the code base we've developed. So we will be in a position to empower more trading and tracking systems around the world of renewables to adopt this. One last point, this is not something I'm directly involved with myself, but I just thought I'd mention to this group that we are working in the US with some of the renewable energy labs. We see this is really around other applications that are a bit more advanced than the one I've been walking through for Energy Web Origin that involve actual physical management of the grid. We see this vision we have of having devices respond and react to different signals as one that's inherently more complex, one that involves physics. And this is something that we are receiving input on, and ultimately we plan to test with NREL and others and PNNL. And with that, I believe that's the end of my formal presentation. And I'm curious to hear what questions you may have for me.
Well, thanks, Doug. That's really, really great. And I noticed a couple of things there that tie into some of the things we're working on. I noticed LO3 Networks or LO3 Energy is one of your partners. They're a local player you've had some contact with. We also have worked with a group called ACE IoT Solutions, who is working with Pacific Northwest National Labs on their Voltron. Is that part of what you're working on when you say you're working with PNNL? Are you engaged with their Voltron team, or is it a different group there?
I'm not sure specifically which team, to be honest, but our essentially, our work, especially, particularly with them and NREL, is focused on our view, is to inform our work on transactive energy systems. So it's really, the ultimate vision, which we've spelled out in what we call the Decentralized Autonomous Area Agent, the D3A.
Mm-hmm.
We put together essentially a visionary piece for this a few months ago. It's available on our website. And I think we are looking to test different things to build in them the functional requirements to make that system more possible. So our work with them is focused on, I think, it's testing different things with combination of pulling data from meters and then having devices respond to different signals and then seeing what the impacts are to, actually with the flow of electricity, which is more difficult than, the example I walked through with REX.
That sounds good. Katie is online from PNNL with us. I don't know if she wants to add any more.
Hi, I actually just sent you a question in the group chat. I was also curious as to who you are working with at the lab, because we do have a pretty substantial transactive controls group. But if you haven't met the Voltron team, we would probably want to get you introduced there. And depending on your research needs on the cybersecurity side of the fence, we also have some pretty deep expertise there as well, and we can help you get connected.
Great. Yeah, and at the end, I'll put my email address up as well. I'd be happy to connect after the call too on that.
Great, thank you.
Yeah, thank you.
The other group that's online that would be interesting to know if you've got any link with is Fourth Mobility, who is the local nonprofit who's driving transportation, energy, electric, the transition from gasoline to electric vehicles. So all the charging infrastructure across the state and other things. I don't know. I'm not quite sure who's on. I noticed there's a Fourth Mobility link. Is there a question from anybody from Fourth?
Yeah. Hi, Wolf. This is Jeanette. Thank you very much. Not more questions. I was very interested, as in Oregon with the low carbon fuel clean standards and monetizing residential credits. This has an interesting application. Would like to get your contact information and discuss that further.
Yeah. And on that point, I think part of my motivation to be on this call, knowing that there's a lot of mobility focused groups in this group, that we see electric vehicles as the second most ripe for application development. So what I mean by that is, we see REX as the one that there's the most excitement and we've made the most progress on so far. So with the Energy Web Origin Toolkit, but we are looking at a number of electric vehicle applications. So far, we've worked mostly with a group called Share and Charge, and then also FlexiDAO. And I know we're planning to put together a showcase in the next few weeks and months on this front. But you brought up the low carbon fuel standard. We've been in some conversations with our affiliate PG&E about the requirement in California, and maybe there being an opportunity to test and start to build an application to essentially move beyond sort of the fixed numbers that are used to date for electric vehicles and add sort of a time component to things. We'd be happy to share more and hear if there's if you guys would be interested in being involved with tests we might be running in this area.
Thank you.
Thanks. Doug, do you, how do you see this moving forward? I mean, the space is quite complicated, associated with regulation around utilities and other infrastructure, and the technology seems to have moved forward, very well, and we can start to do some of these things. But how do you see that interaction? It sounded like you're working with a number of the utilities. How do you see that transition happening? If we saw an opportunity to deploy, you know, a transactive energy system in a development, how would you go about doing that? Would you work through the utilities, or how do you see the technology rolling out?
I'm just going to go back a few slides. So, you know, as I mentioned before, I think what's critical and what's something that it hasn't existed yet for blockchain development in the clean energy space is that, you know, we're still in the process of building this infrastructure. People, you know, anybody can today download the test network, which is it's on the beta version right now. But I think that's one thing that'll help support more applications being developed, you know, blockchain-based applications being developed. You know, when we think about how this works in practice, it's EWF over the next, you know, between now and roughly Q2 of next year, when our system goes live for commercial applications. You know, EWF is leading the work in the infrastructure piece, but then we are not, you know, right now planning to get in the game of building apps, and this is where we see, you know, a combination of, you know, say in the U.S. context, you know, those like Exelon, we hope and expect that they will want to, say, test a market-facing app for the work we're doing with PJM. You know, this is something that, you know, practically speaking, they have an interest in growing the REX market and having people buy REX, you know, through them. And so this, I think, is hopefully a practical example of, you know, EWF is building this infrastructure. We're building these frameworks, and then in this case, it could be Exelon, it could be any other participant can take that open source code we're offering, and then, you know, add some of their own, you know, special stuff to it to make it an application they think is cutting edge, and then they can make money from it. And, you know, I think we see, you know, that's part of the reason why also we've taken an approach of being open source, where it allows for that flexibility for people to make the modifications to meet local regulatory needs. But at the same time, we want to build as much, you know, how can we get to 80 or 90% of the way, for example, with this work on Energy Web Origin, so that it meets most of people's needs, and they just have to make a couple of tweaks to make it, you know, locally, you know, meet local needs. Does that help answer your question? I feel like there's probably one or two areas you might want to dig into more.
No, that was really helpful. I mean, I think there are a number of political challenges here. It sounds like you've nailed the technical challenges, and so I was looking for, you know, but I think we'll probably learn that as we as various people make an effort to deploy. We'll learn a lot about how to work with the regulators and get things done.
Yeah, and I mean, another piece too, to be just pretty blunt about it, is most regulators, and I think in a right way, and in some ways maybe, you know, they're not, they're technology agnostic. So for them, you know, if a utility wants to use blockchain or not, it doesn't and probably shouldn't really matter to them, because it's really about what the application does, and, you know, for example, how it manages data and associated privacy, or does it actually meet the needs of, you know, the mission or, you know, goals of those who oversee the system. So I don't see hurdles in that sense. What has been interesting, just at least personally for me, is the amount of interest just in the technology in and of itself. And I think maybe that's, it's created this notion that regulators would be increasingly concerned. I think there may be concern just because of how blockchain has been covered so far in the news, from, you know, the way that people have talked about Bitcoin being used in some scenarios for nefarious means. And, you know, in other cases, you know, the energy consumption of Bitcoin mining. But I think, again, those are things that aren't necessarily relevant to, say, the work of the Energy Web chain.
That wasn't the concern I had. I mean, I think those can be dealt with. I think, you know, proof of stake can help us with the deployment. Where I was struggling a little bit was, I think it requires, for many of the utilities, it requires a change in business model, right? Today, they generate and distribute energy. I think in the future, if this model works, they're more about the movement of energy, right? They're not the sole creator anymore. There's a lot of generation in the network, and you've got all these dynamic energy resources. And the purpose of the utility is to effectively be a market to trade. And I think that that's going to require a fairly significant shift in how the regulatory infrastructure works. And there's a real challenge in that transition, right? We don't want to have an unreliable network. So we've got to make the transition in a very orderly way.
Yep.
that ensures that we have a reliable network as we move towards these more sort of dynamic resources. And I didn't mean it to imply that they would push back unnecessarily. I think we need a framework that allows utilities to experiment and to move. And I was wondering if Rocky Mountain had been sort of involved in that piece of it.
Sure. I mean, so with the EWF, I mean, I totally get your point, and I think this is in part also why we, from the beginning, have structured it where we're building this ecosystem of energy companies and utilities, because we see, in terms of it, folks adopting it, they're the ones that have the customer networks. They're the ones who can, inform the decisions that regulators make. And that's, I think, we will ultimately lean on them as we move toward more advanced applications. I think some of the points you raised, they're not as problematic for, say, rec trading. But as you're right, I think, as we shift toward applications that are actually able to support the movement of electricity, you're right that there are some important regulatory conversations to have and some changes to make, perhaps. And this also gets into leads me in the interesting direction of, our work is global, and there is in some ways a bit of a greenfield in less developed markets, whether that's Southeast Asia to Latin America, etc. And that's, there is maybe more flexibility to bring these things there first. But it's interesting because at the same time, and this has actually happened in our work on Origin to date, the greatest pain points and the demand and the need to move existing systems over so we can actually adopt clean energy at scale is in the existing markets, which have all this the challenges of changing legacy systems nested within it.
Thanks. That's good. Other questions?
I have actually a quick question, which is probably better answered by looking at Google afterwards. But I'm just wondering. So, I totally get that this is great for avoiding double spend when you have recs that you're dealing with, and I totally see where you wouldn't want to use proof of work in an energy system, Proof of stake is not. Which you have proof of authority.
Yes.
On the slide, and I'm just wondering. So when you have this, lots of small producers who might be injecting some smaller levels of energy into the system, how does proof of authority work in that kind of a?
Yeah. Sure. Yeah, so I'll provide a brief summary about proof of authority, and I'm sure you might have some follow-up questions on it. So for those who aren't familiar with different consensus protocols with blockchain, more well-known blockchains like Bitcoin and Ethereum use proof of work, where essentially it's a free-for-all where anybody can serve as a miner, and you race to solve the respective blockchain's puzzle first, where the puzzle is set to be solved in a fixed amount of time. For example, every 10 minutes for Bitcoin, where the complexity is dictated by wanting to solve that puzzle in 10 minutes to add a new block based on the latest transactions. And that, for those who have read news about energy consumption on Bitcoin and blockchain in general, that means that people inherently increase their computing power to solve a puzzle that keeps getting more complex first. Our system uses proof of authority, which is inherently different in its approach. So even though it's not quite the precise term, if you think of the authorities on our proof of authority system as miners, these authorities are known entities, unlike in Bitcoin where you can be an unknown entity. These are known entities, and they include any of our affiliates who elect to become an authority. So, large energy sector players as well as startups who have a stake in growing this clean energy market. In our system, we have a target block time of roughly 3 to 8 seconds. So that means and that's been the amount of time that's the amount of time that our test network has currently been taking to form new blocks. What that means is, practically speaking, every roughly 3 seconds, all of the latest transactions that have happened over those 3 transactions are sort of put forward. Then an authority is randomly selected, and that authority then has a very short amount of time to solve a somewhat complex but not overly complex puzzle, and then to essentially prove that the transactions being added are in fact those transactions, and then they broadcast essentially what they found to the entire set of other authorities. The other authorities can very clearly know if they have in fact solved it correctly. And at the end, then this is all happening over that short amount of time. The latest set of transactions are added to this shared history. And so practically speaking, this means that each authority has what's called an authority node, which means it's able to not just read and write data, but also add new blocks to the chain. It also means that we will be setting up these authorities so that in terms of security, they are set behind the firewalls of each of these companies, some of whom have very extensive ones. And these systems will be geographically dispersed. So we're in several continents in over 20 countries. So what that means ultimately is that once the system is live, to compromise the Energy Web blockchain, it's not as it is today, hacking one server in the United States where you take down an entire market. Instead, you would have to hack over 50% of our affiliate systems at the same time in order to even have a chance at undermining the integrity of the system. So that's, I think, something interesting. But I think also with our proof of authority, our choice to go after proof of authority, this was one of the reasons why we wanted to build an energy sector specific blockchain. It's increasing the frequency at which we can form new blocks. So rather than it being, say, 10 minutes or a few minutes in the Bitcoin and Ethereum blockchains, but also then not quite related to proof of authority, but some of the other work we're doing to actually maximize throughput, given the sheer volume of transactions that happen in the energy sector and the increase we expect as we have devices actually participating more. These are all things that are built into, actually, one of the pieces we're dedicating a significant amount of time to is governance. And this relates to, governance is the piece that overlaps with our proof of authority system that we're designing and testing, as well as, application developers. So let me say a quick point. I realize I'm going slightly off topic, but the Energy Web blockchain will have a token, or we plan to have a token, where that token is to pay for gas or to pay for anybody's usage of the Energy Web chain, in part to protect against cyber attack, where it makes attacks not free. And so people can't run cyclical attacks that create traffic jams. And with this token, this is something that really, it's less of a consumer-facing piece compared to other tokens you may have heard about. It's something that really only the application developers, those that are actually running apps, will have to interact with and handle. What's also interesting, and then I'll pause, is that application developers are actually will serve a leading role in improvements that are made to the chain over time. So we have an entire procedure in place for, or at least we have a working draft on a procedure in place for when how improvement proposals will be agreed upon, tested, and implemented, as well as then somewhat related to that, if there's ever an emergency for whatever reason, how that would actually be operationalized. But let me pause there.
Richard, did you have a follow-up?
No, thanks. That was helpful.
Great.
So I guess the one thing I mean, this is just a quick thing.
Yeah.
So as a producer, as a small producer, you may or may not have authority in that sort of proof of authority regime.
Oh, so yes. So to be very clear, the Energy Web blockchain is its own blockchain. It is separate from Ethereum, but it uses the same language, the same programming language as Ethereum, and it uses a different consensus protocol. And with proof of authority, you can only become an authority if you become an affiliate of VWFs and you go through our KYC and anti-money laundering process.
Right.
And so, but at the same time, the Energy Web blockchain is public. Anybody can submit transactions and use apps that interface with the Energy Web chain. But in order to be in a position to actually validate and add new blocks, you have to be an authority and go through the process of what it takes to become an authority.
Got it.
But practically speaking, a few months ago, I tried to buy renewable energy for my condominium building in Washington, DC. The process took several months, about 10 phone calls, dealing with PDFs back and forth with a broker. What I want to build an application for people like myself, where instead I would love to go into an app, say, on this app, I want to buy this amount of renewable energy for my building, and I need it over this time frame, and this price works fine, and then do it. At the same time, I also want to, we are looking to offer a system not just for any-day customers like you or me, but also like the largest participants on the market, from Exelon to Microsoft, and they would all be able to use it, and submit transactions and make deals. But then only the likes of, in this case, Exelon, in this example, would actually also have the ability to be the authority, where they would. I'll just be upfront about it. A couple of times I've gotten questions about people saying, "Well, some of these affiliates of yours, like Shell and Equinor and TEPCO, many of them historically are oil and gas companies. Won't they try to block clean energy investment?" The thing is, they won't be able to see because of privacy protections, they won't be able to see the nature of the transactions that are happening. They're just validating that transactions did in fact happen. And they have the financial incentive to do that, because if they fail to sign a block over the 3-second time frame, the next authority is then selected to sign that block. And over time, if a particular authority continues to have problems, whether on purpose or for whatever issue they have, there is also a process to remove authorities if they are not supporting the maintenance of the shared system.
Got it.
Other questions?
I realize we have about 10 minutes left, so time's quickly winding down.
Yeah. Any other questions? And actually, we can finish early if there are no other questions. This was really excellent, Doug. Thank you.
Sure.
Did anybody have questions? Well, thanks, Doug. I really do appreciate it. Very helpful. I did record it. If you're okay, I'll put that out on the web. You can point people at it. But I think this was very productive for us and much appreciated.
Sure. And just briefly, one on that specific point, if you do share it on social media, feel free to tag EnergyWebX at EnergyWebX. Just they'll probably retweet it if you do that. If you want to distribute that way. And for those of you who are based in Washington, I'm here. So if there's a conversation that you're interested in having, let me know. I'm based at Farragut Square and happy to grab a coffee. So an invitation.
Well, that's great. I do appreciate it. If I'm in town, I'll give you a call, or I'll come through Jeffrey.
Sounds good.
Sure. Cool. Thanks, everyone. Have a great day.
Thank you.
Cheers.
Thanks, Doug. Thanks.
Bye.
Thank you. Bye.